So in this example, we're told that we have a 1/2 farad capacitor, and we're told that there is a current flowing into the capacitor that is defined by this 16 cosine 4t. And we're also told that the voltage on the capacitor is 0 at t equals 0 seconds. And so they're asking us to solve for a couple of things here. The first one is at pi over 8 seconds, what is the energy stored in the capacitor? And then at pi over 12 seconds, what is the power delivered to the capacitor? So a couple of things here to figure, so let's see how this works. So the first thing we're going to note, just a couple of things here. The first is that the current we said was defined as 16 cosine 4t. And again, that's just straight from the problem definition. And then also that the capacitance is equal to 1/2 farad. Again, straight from the problem definition. And so first thing we're going to work on is finding the energy stored at pi over 8 seconds. So before we do that, we need to get an expression for the voltage. We're going to need that for both parts of this problem. So we recall that for a capacitor, we can find the voltage, our expression for the voltage, by integrating over some time interval of the current with respect to time. So in this case, 1 over c is going to be 1 over 1/2. It's going to be the integral from 0 to t, and then it's going to be 16 cosine 4t dt. And we can bring the 16 out, and then we'll have an integrating factor of 4. So that'll make the multiplier then 2 times 16 over 4. And then the integral of cosine then is just sine 4t. And when we multiply that out, we get 8 sine 4t. So here's our expression for the voltage. So now we have the expression for the current, expression for the voltage. So now let's see what we need to calculate here. So for the first one, we're going to look at the pi over 8 seconds, and they want to know the energy stored. So we'll come here and say in green, that's what we're doing. So we need to recall then that for energy stored in a capacitor, that's defined as 1/2 times the capacitance times the voltage squared. And again, recalling that at t equal to pi over 8, which is where they've asked us to calculate this, then we need to calculate what 8 times the sine of 4 times pi over 8 is. And so that's going to be 8 times the sine of pi over 2. Well, the pi over 2 is just equal to 1. So this means that our voltage then is equal to 8 volts at that time. So that being the case, we can come back and then say W then is equal to 1/2 times the capacitance, which is 1/2, times the voltage, which is 8, squared. And so when we calculate that out, we should get 16 joules. So that's the answer to the first part. At pi over 8 seconds, we should have a stored energy of 16 joules in the capacitor. Okay, so next we're going to look at the time interval of pi over 12. And at pi over 12, they're wanting us to determine the power delivered to the capacitor. So we'll come down here and do this in blue. So we need, for power, we need voltage and current. So again, this is at t equal to pi over 12. So let's calculate both of these values then. So the current, which we've defined up top, will be 16 times the cosine of 4 times pi over 12. And so that's 16 times the cosine of pi over 3. And so that's going to be 16 times 1/2, because that's what the cosine of pi over 3 is. And so that comes out to 8 amps. So that we'll need that here in just a minute. And then likewise our voltage. So our voltage is going to equal to 8 times the sine of 4 times pi over 12. And so it'll be 8 times the sine of pi over 3. And so that's 8 times the square root of 3 over 2. And so that'll be 4 times the square root of 3 volts. So then we need to calculate the power. So we recall, and that power is just equal to the voltage times the current. So in this case, the voltage is 4 times the square root of 3. And the current is 8. And so that'll just be 32 times the square root of 3. Or if you want to get that out to a number, that's about 55.426 watts. So that's the answer to the second part of our problem.